Continue with practical techniques of root cause analysis for effective problem solving. Uncover hidden risks with fault tree analysis solutions. Let's look at a definition of fault tree analysis. Fault tree analysis is a type of failure analysis examining an undesired system state. Fault tree analysis was originally developed in 1962 at Bell Laboratories by H. A. Watson under a U.S. Air Force Ballistic Systems Division contract to evaluate the Minuteman I intercontinental ballistic missile launch control system. So, what is fault tree analysis? Fault tree analysis is a systematic and deductive method used to understand and analyze the occurrence of a problem. It follows a logical sequence from one stage to another, moving from the top to the bottom. FTA is commonly employed in various fields, such as system safety and reliability analysis, reducing the rate of safety accidents, investigating and diagnosing the root cause of downtime, developing logical thinking approaches, and understanding how problems occur. Why is fault tree analysis important? The application of fault tree analysis is of significant assistance in the system safety and reliability analysis, decreasing the rate of safety accidents, investigating, diagnosing, and identifying root causes of the problem, developing logical thinking approaches, deep understanding of problem occurrence, identifying solutions to reduce problem risk, prediction and probabilistic risk assessment, prioritizing maintenance, optimization of resources, cost control and systems performance. Basic steps of fault tree analysis. The fault tree analysis main steps are: identify the top unwanted event, identify events and conditions, determine the relationship between conditions, connect function event boxes, investigate and add conditions, break the chain of cause and effect, add solutions and actions, verify preventive measures. Logical gate symbols, the basic elements of fault tree analysis. In fault tree analysis, logical gate symbols represent the relationships between events and causes. These symbols help diagrammatically map the fault tree, enabling the analysis and identification of potential causes for undesirable events. These gate symbols are crucial in determining the root causes of problems and understanding the overall system behavior. The following part will describe the principal symbols employed. Top event gate. The top event gate represents the undesired event analyzed in the fault tree. It serves as the starting point for the fault tree analysis, focusing on understanding and mitigating the causes leading to the occurrence of the undesired event. For example, if the top event is a production line stoppage, the causes leading to this event could be a main engine breakdown or overheating issues. End gate. The end gate is a logical gate symbol that indicates that the subsequent effect will occur if all inputs effects exist simultaneously. In other words, it represents a condition where all specified events or causes must occur for the output event to occur. In fault tree analysis, the output of an end gate can be connected to any fault event element, indicating that all the related causes are necessary for the occurrence of the top event. OR gate. The OR gate symbolizes that the output effect will happen if one or more of the inputs effects exist. In contrast to the AND gate, where all inputs must occur, the OR gate provides flexibility by allowing any one or a combination of inputs to lead to the output event. This gate is commonly used when multiple potential causes can result in the top event. Exclusive OR gate. The exclusive OR gate produces an output when one, and only one, of the input events occur. Two different input values characterize it. If there are more than two inputs, the output occurs if the number of input events is odd. This gate is used when mutually exclusive causes exist, and only one can contribute to the top event. Inhibit gate. The inhibit gate signifies that the output event happens if the input event occurs under a specific enabling condition specified by a conditioning event. It introduces a conditional relationship between the input and output events. The conditioning event sets the enabling condition, and if the input event satisfies that condition, the output event occurs. This gate helps analyze scenarios where the occurrence of an event depends on specific needs being met. Basic event. The root cause. The basic event gate represents the lowest level of causes identified in fault tree analysis. It encompasses the base events that contribute directly to the occurrence of the undesired top event. Identifying and addressing the primary events is essential in effectively preventing or reducing downtime. These events serve as the root causes of the problem and form the foundation for further analysis and mitigation strategies. Fault tree analysis example. Here is an example of fault tree analysis. Understanding the logical gate symbols used in fault tree analysis is essential for accurately mapping the relationships between events and causes. By utilizing these gate symbols effectively, fault tree analysis can uncover the root causes of problems and implement targeted solutions to mitigate or prevent undesirable events.